Hello and welcome. Today, we're going to tackle a word that is, well, everywhere. It shapes our entire world. But if you stop and think about it, its actual meaning can be kind of slippery. So what exactly is a science? Let's break it down.
I mean, you hear this phrase all the time, right? Trust the science. And it carries a lot of weight. But for that to mean anything, we really have to know what we're talking about when we say science. Is it just a big book of facts? Is it a special way of doing things? A mindset? That's really the big question we're going to dig into.
So to get our arms around this, we're going to build ourselves a little mental toolkit. Think of it as a set of core ideas, a few key concepts we can use to look at any field of study and ask, okay, does this count as a science?
Okay, first tool for our kit. At its very core, science isn't a destination, it's a journey. It's what you could call the relentless pursuit. But a pursuit of what, exactly?
It's really just a quest to make sense of, well, everything. From the tiniest little microbes to the most distant galaxies, science is all about finding the patterns, the rules, the laws that make the universe tick. It's really an adventure that's fueled by pure, simple curiosity.
All right, so if curiosity is the engine, what's the road that it drives on? That brings us to our next tool, the foundation of evidence. And let me tell you, this one is a non-negotiable. It's the bedrock. This is what people really mean when they say something is evidence-based. It's not about opinions or feelings or what somebody believes. It's all about what you can actually observe, what you can measure, and what you can test out there in the real world. Empirical inquiry just means we let reality be the final judge of our ideas.
And how do we gather that evidence in a way that isn't just random? Well, that's where the scientific method comes in. It's a system, a structured approach. You start with a testable idea. That's your hypothesis. Then you set up an experiment to see if it holds up. You carefully look at the results, and from that data, you draw your conclusions. It brings some much-needed order to the chaos of discovery.
Now for what might be the most powerful and, honestly, the most misunderstood tool in our whole kit. I'm talking about the falsifiability test. This is like the ultimate bouncer at the club of science. It decides who gets in and who gets turned away.
So the idea here is actually pretty simple. For any claim to be considered scientific, there has to be some way, at least in theory, to prove it wrong. See, science isn't really about proving things right. It's about trying your hardest to prove them wrong and seeing what survives. A truly scientific idea has to put itself out there. It has to be vulnerable to being shot down by evidence.
And this example makes it crystal clear. Look at the claim, all metals expand when heated. That's scientific because we can test it. All we need is to find one single metal that shrinks when you heat it, and boom, the whole theory is busted. It's falsifiable. Now look at the other one. This was fated to happen. How could you ever prove that wrong? There's no experiment you could possibly run. It's an interesting belief, for sure, but it's not a scientific hypothesis.
Okay, let's grab our next tool and see how this all starts to build. A huge goal of science isn't just to collect a bunch of interesting facts. It's to create knowledge that has both objective and predictive power. This is what makes it so incredibly useful.
So science is really shooting for three main things. First, there's generalizability. You don't just watch one apple fall. You figure out a principle like gravity that applies everywhere. Then you have predictability. You use that principle of gravity to, say, predict the path of a rocket heading to Mars. And finally, there's objective rationality. This is all about trying to remove our personal biases by using things like peer review so that we're evaluating the evidence as impartially as humanly possible.
You know, it's so easy to picture science as just a series of lone geniuses in lab coats having these big eureka moments. But the reality? It's way more of a team sport, and it's played over a very, very long time. Let's look at how science actually grows. I just love this quote. It perfectly captures this idea that science is cumulative. Every new discovery, every new insight is built on top of all the work that came before it. It really is a group project that spans generations. So you see, science isn't just a list of facts. It's this dynamic, growing, interconnected web of knowledge. It moves forward piece by piece, and the lines between fields like physics and chemistry and biology are getting blurrier all the time. Actually, some of the coolest discoveries are happening right at those intersections, where different disciplines team up to tackle really complex problems.
Okay, for the last tool in our kit, we've got to zoom out a little.
See, science doesn't happen in a bubble. It's shaped by these really deep questions about knowledge and reality itself. And that brings us to the boundaries of science.
Way down at its roots, science actually leans on philosophy to help with two massive questions. The first one is about knowledge itself. How do we actually know what we know? That question shapes the entire scientific method. And the second one is about reality. What's fundamentally real? And that question guides what science even decides is worth investigating in the first place.
And this all leads us to a really fascinating and, yeah, a pretty challenging question. If we use the toolkit we just built, where do fields like psychology or economics fit in? I mean, they study the messy, complex world of human behavior. They use empirical methods, but can their findings be as predictive or as falsifiable as, say, physics? The lines here aren't always so clear, and it's a topic of some pretty serious debate. So, after all that, what is a science? Well, as our toolkit shows us, it's way more than just a set of methods. It's a whole process, one built on evidence, objectivity, and a constant willingness to be proven wrong. But really, at its very heart, it's powered by that relentless human spirit of curiosity. So maybe the next time you hear someone say, trust the science, the real question to ask is, are we trusting a static set of facts, or are we trusting in this ongoing, never-ending quest to simply understand?